Hello and welcome to another variable acceleration question from 2019. This was question 1. I can see it's variable acceleration once again because if I differentiate this, whilst the x component is going to be constant, so that looks like constant acceleration in the x direction, the y component is going to be varying according to the value of t, and so this is variable acceleration. And so just a reminder, s, v and a, we differentiate if we need to go down 1, and we integrate if we need to go up 1 in these questions. Yeah, use this, and basically that is all you need for a variable acceleration question, I would argue. So what do we got here? Particle moves its velocity is given by this. I'm just going to write this in a more convenient format. As you know, I'm a hater of I and J notation. Okay, that's good. When t equals 0, the position vector is minus 20, 20. Okay, that's very important because we've got the velocity and we know the position vector there. Now, it wants us to find the acceleration first when t equals 4. So I'm just going to differentiate that to find the acceleration. And so I'm going to say a equals 6, and the y component, no, well that's going to be minus 7.5 t to the power of a half. So reduce the power by 1, and I've multiplied by the old power. And t equals 4, and so a is going to be 6, and then 4 squared is 2, 2 times that is minus 15. Now, I always think in these, like, I don't know about you, but I'm always like worried, do they want the acceleration as a vector or acceleration as a scalar? Personally, I think either's absolutely acceptable, but I'm going to just quickly find the link for that just in case, because it doesn't take a second to do Pythagoras' theorem. So, as a scalar, you might even write it down so it's nice and clear to the examiner if you want the scalar. The magnitude of acceleration equals, we'll check it at the end to see if they wanted just a vector. I suspect the vector will be fine. Square root of 6 squared plus 15 squared, which is 225 plus 36, which is 261, I think, root 261. Okay, let me just check that on my fingers. 225, 354555, yeah. So that would be the magnitude, but I think the vector's fine. Okay, part B, position vector when t equals 4. Okay, so we're going to have to integrate here. So s equals, integrate 6t, you get 3t squared, plus c1, integrate minus 5t to the 3 over 2. Well, we're increasing the power by 1, so we'll put that as t to the 5 over 2 first. And then we're dividing by 5 over 2, which is the same as timesing by 2/5, which I think is going to leave us with minus 2. Yeah. Now, if I times that by 2.5, 2 times 2.5 is minus 5, and yeah, that's looking good. And then plus c2. But we've got to make sure that we're going through this point when t equals 0. Yeah. So we can actually find the value of c1 and c2. So t equals 0, s equals minus 20, 20, and I'm just going to plug this in to make sure that this works. So I get, can you see here, because t is going to be 0 there, c1 is just going to be minus 20 and c2 is going to be 20. And so actually it's going to be 3t squared minus 20 and minus t, 2t to 5 over 2 plus 20. Cool. Be slightly careful if you had x, e to the power of t or something like that, or cos t, then t equals 0 is not going to make it 0. Watch out for that. That's an easy trip up. Okay, but now we should be fine. We've got to find a position vector when t is 4. So at t is 4, where is s? Well, we're going to have 4 squared 16 times 3 is 48, minus 20 is 28. 4 squared root is 2 to the power of 5 is 32, times by minus 2 is minus 64, plus 20 is minus 44, and that is the position vector of t. That's it. Okay, hope you enjoyed the video, hope it was useful. Keep up the good work. Bye bye.